Hello everyone, my name is Shi Jie, comes from Dongsil University Graduate School, Visual Content Department. Today, I want to report this research on animation data mapping for efficient motion capture. Part 1 is abstract, Part 2 is introduction, Part 3 is related research, Part 4 is experiment, Part 5 is conclusion. The final part is references. Part 1 Abstract. The field of animation production increasingly relies on efficient motion capture technology to achieve more realistic and vivid character animation by capturing real-life motion data. In this context, this study is dedicated to comparing two animation data mapping methods, mocap matcher and bone retracting. The similarity between these two methods lies in mapping animation data, but there are also differences in details. Currently, existing mapping methods often face the challenge of detailed setup processes and time-consuming workflows when dealing with complex schedule structures. Through in-depth research on mocap matcher and bone retracting, explore the differences between the two to explore more efficient animation mapping tools. This study uses a standardized motion capture data set as the experimental object and compares the mapping efficiency and work efficiency of the two methods through experiment. The results shows that mocap matcher not only eliminates the complex bone chain setting process while maintaining mapping quality, but also performs better in terms of work efficiency. Finally, this study puts forward suggestions for future research to further improve animation data mapping methods and promote the development of motion capture technology in the field of animation production. This research aims to provide the animation industry with a more efficient and simplified motion capture data mapping solution and promote innovation and progress in the animation production progress. The keyword is motion capture, animation mapping, bone retracting, and mocap matcher. Part 2 Introduction. In today's booming animation production field, creators have placed higher expectation on presenting more realistic and vivid character animations. As a key technology, motion capture technology injects life to characters by capturing real-life motion data, driving the animation industry forward. However, as animation production becomes increasingly complex, processing complex bone structures and achieving efficient animation data mapping has become a new challenge for creators. Just the comparing background. This study focuses on comparing two commonly used animation data mapping methods, mocap matcher and bone retracting. These two methods work together to map motion capture data to the target character's movements, but their implementation differs in details. In this moment full of innovation and challenges, the field of animation production urgently needs more efficient and smarter animation data mapping tools to cope with the ever-increasing production standards and the time pressure. Current mapping methods often require a long and cumbersome setup process when dealing with complex bone structures, which puts a considerable burden on procedure. Through an in-depth exploitation of mocap matcher and bone retracting, this study aims to discover a more efficient animation mapping tool, focusing on simplifying theory setup steps while maintaining higher quality mapping. By using a standardized motion capture dataset, we will compare the performance of these two methods in detail and in terms of mapping effects and work efficiency, and pursue the creative inspiration brought by the process of improving animation production efficiency. Ultimately, the vision of this research is to create a more efficient and simpler motion capture data mapping solution for the animation industry, opening a new chapter in animation production for creators. Part 3, Related Research. The first is motion capture. Motion capture is a technology used to record and capture the movement of objects in the real world. Typically, this technology is widely used in film production, video game development, medical research, sports science, and more. Through motion capture, the movement of humans, animals, or objects can be accurately captured and recorded, and then this movement data can be applied to virtual characters, models, or other digital scenes to make them present real and natural movements. Lastly, proposed a viable system that aims to solve the challenge of acquiring movement data in everyday environments by using inexpensive linear one-on clothing combined with ultrasound and temperature measurement. The system is able to flexibility and protecting record a variety of movements, including actions that are traditionally difficult to capture. Motion capture systems usually include scenarios, cameras, computer software, and other components. These scenarios can be intrude scenarios, offshore scenarios, electrogenic scenarios. They are used to detect and record the position, direction, acceleration, and other data of objects. With the development of motion capture technology, the American Magic Company was established in 1983. Motion capture actors use the equipment to interact with other characters. As shown in Figure 1, Figure 1 motion capture technology is used in movies. 3.2 Animation mapping. Animation mapping refers to the process of mapping a set of motion data from one source object to another target object so that the target object imitates or simulates the movement of the source object. The main goals of animation mapping is to achieve more realistic and natural animation effects, allowing visual characters or objects to move and interact in a vivid and realistic way. Holden proposed a real-time solution for animators working in character action design, mapping animation data from the character's binding space to its selected space by learning from example animation sequence constructed by an animator through nonlinear regression, mapping from skeleton space to binding space. This gives animators the freedom and attach any motion sixes algorithm to different rigging and animation pipeline. Animation mapping is not limited to character animation, but can also provide more realistic and engineering animation effects for various applications in the field of digital. 3.3 Mocap Matcher. Mocap Matcher is a part of advanced skeleton, the most frequently used tool in the cracked bone blinding process. It focuses on providing animation data mapping for motion capture. It is widely used because of its fast, efficient, and convenient characteristic. 3.4 Bone retouching. Bone retouching is an important technique often used in a field of animation, especially when working with motion capture data. This process involves mapping actions on a source bone structure to another target bone structures in order to adapt to different characters or models. The figure 2 shows the principle of bone retouching. In motion capture, different characters may have different skeletal structures, as a body proportions, number of joints, and arrangement may vary. The purpose of bone retargeting is to ensure that motion captured from the source character can be applied smoothly to the target character without causing a nature effect. Research shows that although this technology has been applied in many fields, the production time is long because of the need to set up a large number of value bone chains in the process. In this article, Elberman proposed a deep learning-based framework that achieves effective transfer between different skeletal structures without the need for display pairing between motion data, providing an inventive motion redirection tool for animation production and game development. Figure 2. Name matcher operating in Part 4. Compare the animation mapping effects of mocap matcher. And this section describes these sets of the idea in details and use experimental results to illustrate which mapping tools has the best effect and the highest time efficiency. Figure 3 is the idea map. 4.1 How mocap matcher works. Mocap matcher is a function of the advanced skeleton plugins that is used to convert motion capture animation data. The effect of animation transmission is achieved by scanning motion capture data, automatically smoothing T-pose, and automatically baking animation data, as shown in Figure 4. Part 2. How bone retargeting works. The pipeline of bone retargeting technology is to map the source animation data to the target bone character in Unreal Engine when ensures that the action or T-pose after setting accurate retargeting sets the same bone channel of two different bones. Action data is transferred during the operation. That the final target character has data of the source animation as shown in the Figure 5. 5-part experiment. 5.1 Experimental methods and design. The experiment in this section uses the material model tuner is advanced skeleton as a target model and use motion capture animation as a source animation data. Carry out mocap matcher and bone retargeting operation respectively. Compare the final animation transfer effect of two methods and the process time, and find out which tool is most suitable for motion capture animation transfer. 5.2 Experiment procedure. First, conduct a bone retargeting mapping experiment. Import the motion capture data into Unreal Engine. Set up accurate retargeting and then set up a large number of lip bone chain channels, as shown in the figure. Finally, set up T-pose posture calibration. The experiment found that the final animation effect was better, but a lot of work time was spent on the skeleton chain setting, as shown in the Figure 6. Then conduct a mapping experiment with mocap matcher. Import the motion capture data into Maya for advanced skeleton blending and follow the steps in the mocap matcher interface to perform animation mapping on the tuner model. The experiment found that the animation effect of mocap matcher is almost the same as that of bone retargeting, but based on the same effect. The operation steps of the former are simpler and more time-saving, as shown in the Figure 7. 5.3 Experimental results. By comparing the final animation effects of the two, the experimental results show that the mapping effects of both are relatively good. However, in terms of operation step, mocap matcher only needs to operate according to the step, while bone retargeting needs to set up a large number of mapping channels for lip bone chains. Based on the picture effects and the production time, mocap matcher has the highest motion capture data mapping efficiency. 6-part conclusion. This study aims to compare two animation data mapping methods, mocap matcher and bone retargeting, to improve animation production efficiency. Through in-depth research and experiments, we conclude that mocap matcher simplifies the detailed bone chain setting while maintaining mapping quality significantly, improving work efficiency, and provides a quick solution of animation transfer, although bone retargeting performs well in mapping effects. Its complex bone chain setup process consumes more time and effort. There is almost no obvious differences in the final animation effects between mocap matcher and bone retargeting. However, with the same effect, mocap matcher is simpler to operate and the enhancement tools that up best. In summary, this study highlights the advantages of mocap matchers in terms of efficiency, provides the animation industry with a more efficient and simplified motion capture data mapping solution, and promotes innovation and progress in the animation production process. Future research can further improve the mapping method and promotes the computer-sensitive development of motion capture technologies in field of animation production. The last part is references. This is my references. Thanks for watching.